so I cannot draw something, but hopefully you can understood lah what I want to say today. Right, so uh, any question before we want to go to the next? No question. Okay, go to your e-learning. Go to your e-learning and download everything for the week 7. No, doctor. Why no? Why no, Faris? Indumati, why? No, doctor. You go to the e-learning. E-learning. I share the screen. Not yet. Okay, today I will not open my video. Or I hope it's okay because lighting also not so good here. Okay, so we left off the chapter 2 before you for the next week examination. So we have an examination CA, we call it as a CA test 1, continuous assessment 1, which is we have objective and a few question for the chapter 1 and chapter 2. Chapter 2, I think chapter 2. I will notice you again at the group the detail of the test for next week. Right, so are you hear me now? You ready? I'm not sure is it clear or not, because some said here no, doctor. I don't know what is no. What is the no meaning? Are you here? Yes, okay, clear. Alright, so go to the course your e-learning. So we have a notes there. Okay, regarding your class at Monday night, actually if I have not mentioned we have class, actually at the Monday night you should go through to your e-learning punya material lah. Alright, because actually this week I'm in quarantine for 5 days. Okay, so bit busy, and if Monday night no class, so this is automatically go to your e-learning and do something that make a preparation and exercise. Right, so today is, this week is week 7. So you should download everything here, and I just saw that 4 of you just go through the exercise here. So hopefully you can download the Excel worksheet here, because this Excel will give you a calculator to solve for your examination. So later on you just modify some little bit inside of the calculator that we already put in the normal table. So you need we just using Excel for solving the question. Okay, so chapter 2, normal probability distribution. So the last chapter we will cover the continuous probability distribution, normal probability, standard normal probability, and normal approximate of the binomial and Poisson distribution. So this is week 7. So we'll still discuss on the MCT, MD, measurement central density, and measurement of dispersion of the distribution. And then we calculate what is the probability using the cumulative table and using Excel. So you need to know how to use table and Excel. So if you go, actually this note is extract from your textbook. So continuous probability distribution, we have discrete random variable, and then we have continuous random variable. So discrete meaning a value. So we have not involved of the decimal. We not involve the decimal. Okay, no decimal here. So here no decimal, but here is we consider all number, okay, all number, including decimal lah, include decimal. Okay, including decimal. So that is continuous, which is length, depth, volume, time, and weight. For this example lah, for actually we have another example later, but for this discrete, number of sale, number of call, number of people. So we do not have option for the decimal, so we call it as a discrete random. So if a random variable is a continuous variable, so random variable is a continuous variable, and then its probability distribution is called a continuous probability distribution. So the distribution should have these 3 conditions. So these 3 conditions. First of all, fx should be non-negative. always 0 or equals to always positive or equal to 0. No probability. So what meaning the no probability, no chance to not happen, nothing a certain for sure there is no probability that, so there is no chance to happen. So the total area under the curve is equals to 1 for fx. This means that if we total area under the curve, we know the curve for the normal is like this. So and then we have this. So he called it as the total area under the curve should be 1. But if you go to the table, actually we just consider half of this. So there is something you need to calculate, to think first before you make a calculation. So first is identify and draw where is the area that the question need. And then for the 2 point, if you have 2 point from A to B, and then the other under the curve is from A to B for any A and B. So if we have A here, B here, so the area is covered is only this area lah, not the rest is not. Alright, so normal distribution, bell, we call it a bell shaped graph or symmetric graph. Okay, then we have this notation. So for those, we have a mean and variance. So mean of this is nu, variance of x is sigma squared. Standard deviation is square root of variance. Okay, you should remember this, because if in the Excel, the formula should be equals to square root RT, then you bracket what is the number of the variance that we get from the question. Okay, this is example. So example of the normal distribution question. So as you can see that we have already highlight this distribution is approximately normal distribute with this mean. So you need to identify what the data that we have. So we have a standard deviation, and what is the percentage of customer we spend less than. So this is the question. So you need to understand what the formula that you need to convert. So again here you need to identify what is the distribution here. The word the keyword is distribution of the number is normal here. Is the normal, and then the probability between, okay, between these two number, okay, these two number. So there also a normal distribution. The question will state the keyword of normal distribution. That is the key lah. Right. So properties of normal distribution, we have bell shape, new, mean, median, mode, equal. So this is the standard deviation. The standard deviation is this, and then only one mode, consists of one mode, location determined by mean, spread determined by standard deviation, random variable, and so on lah. Okay, I think okay, this also the key also for the normal distribution. So if we have a few type of graph for the normal distribution based on the value of the standard deviation. So if we can see here, the mean is equal, the standard deviation is different. So it will give a different kind of shape, almost the similar but different. Okay, and then here we have two normal distribution with different mean. So new is mean, new 1, new 2 is different, but here is not different. And then for the shape here, standard deviation is equal, so that we can see the curve is similar lah, same lah, dia punya bentuk dia sama. Alright, and then if the norm the standard deviation different, mean different, so we have this kind of then you can see in the textbook they are also discuss on this. We can see the difference of the normal distribution based on mean and standard deviation. Okay kelas, okay kan ni? Ke saya cakap seorang-seorang? Okay?
Okay.
Boleh. Alright. Next, kita pergi kepada seterusnya. Next is standard normal probability distribution. We have this notation. So normal distribution with parameter nu 0 and sigma square equals 1 is called a standard deviation normal distribution. Okay, benda ni kenapa benda ni timbul? Nanti dia akan nampak dia punya consequence dia tu. Okay. Standard deviation, normal probability distribution. Okay, a normal distribution, and then we want to shift this graph to the standard normal distribution, which is for the standard normal distribution, we just only deal with 0 and 1. Okay, 0 and 1. So the value is in between that. Okay, so here to make the standard normal, so standard normal, so we need to have a measurement how to make it standard. So we need to have a measurement how to measure. We need to have a formula. So we just use this formula to make this data become standard normal. So from X value to Z value. If X value meaning there is a normal distribution, but if we call it as Z, so Z meaning the standard normal distribution. We already changed by using this formula. Okay, so the idea is because it's a symmetry, so we divide by 2, so we have 0.5, the total area here. Okay, for Z lah. So you need to remember the keyword is standard normal. If the normal probability is different with the standard normal, just easy, because standard normal you just deal with Z and 1 for the total value of the total area under the graph, right? Okay, calculate standard normal distribution. Okay, calculate probability using table. So how to use the table? So area under the graph standard normal, find the probability. So under the table, if the given is Z here, so how to determine? If we call it as an upper tail probability Z alpha, so we just need to know what is the position of Z that we want to determine, and then we need to remember that. First is remember, check the reference of the table. Some table give a answer for the whole area here, but almost of the table use only you just start from 0 until Z. So before you go to the table, if you go to the table at the back, at the appendix, so we can see at your table standard normal. Okay, standard normal page 238, 238. So we have area under the graph 0.z. So the everything value here is refer to the graph from 0 until z here. So not cover for this. So that's why after this you need to, that's why I want to remember you again. First of all, to deal with this probability, you need to identify where is Z. You need to sketch first. Make sure you sketch first where is Z. So if you can see here, from 0 until 0.24, so the area cover here is 0.0948. So this value is big from where? 0. So we Z value is 0, 0.2, okay, 2, and then we get this is 2, then we get 4, 0.098. For this 0.3577. So you go to the back of your appendix. We can see here. So between 1.07, 1.0, so 7 is here. Okay, 1.07. Okay. Okay, this is how to determine the probability area and so on. So how about negative here? How about negative here? So okay, greater than. So we know that first of all we sketch the graph. They want to have 0.03 here. So greater than this area. But the table is cover this area. So what should you do? You need to 1, meaning total area 1 minus this area. So what is this area? So what is this area? 0.03 0.03 1 minus 1 minus what? 1 minus the area that given lah. So 1 minus the area that we will have here, 0.03. 1 minus 0.0120. So 1 minus 01. 0.012. So we will have not 1. Why? Because of not 1. How to sketch here? Okay, we have this area, and then actually in the graph we cover only this area. If we cover all everything here, so that there is 1 minus this area lah. But because of the graph, so the graph, the value 0.012 is only covered in this area, so we take half. So sorry, here 0.5 minus this value, so that you will get 0.488. Okay, boleh tak? And then if a negative, so if a negative meaning this from here, so z equals to 1.03, negative 0.3, so meaning we cannot find directly from the graph, but what we can do is we terbalikkan dia. If we have this, okay, we have this this is 0 here, so this is negative 1.3. You said that less, right? Less than 0. So less than, so this is less than, so so the cover that they need to ask is here. So what should you do is you switch this graph. If you switch this graph, you will get like this. Cannot, tak jadi. Kita terbalik dia, letak cermin dekat sini. We put the mirror here, and then actually this area is equals to so if we put the mirror here, so the area will be the same with the, if we say z equals to 1.3, so we have 0 here. So we want this area, so you can see here, what should you do? 0.5, okay, 0.5 minus P, the area under the graph of PZ less than 1.3. Okay, and then after that you will get the answer. Okay, you will get 0.1515 in between here. So if between here, so first of all you sketch first. We can see where is the 0.51, and then we have 0 here, we have 0.02. So in between, so if we sketch here, if we have sketch here, so we have here is negative 0.53, for example. and then we have 0.2 here. So the area cover is this area and this area. So how to calculate? Based on the table. So based on the table, we have these two area. These two area, we have. So you need to identify the area first, and then after that you calculate. Use cash first. So this area, and then we plus with the area of negative here. So area of negative here kita terbalik macam yang kat atas ni. So macam kita terbalikkan dia, so kita akan dapat, so we will get this. Okay, we will get this area 0.53. We take the positive area here. Okay, then after that we get the value of the value of this, which is 0.23. I hope you can manage to do it. So because it is the most important idea here, to identify where is Z, and to identify and know how to calculate after you identify the position of Z. For example, here if you go there, so this is actually the solution. They already give a solution here. So you will get this cover. So for the first is direct, second is not really direct, but we need to change first. Change into here. You need to change here. Then you get from the table, you get this number, and then 0.5 minus this. For between meaning that what I said, this area plus this area, so you will get the other. So 0.2. Boleh? Okay, so next we go to the upper tail probability. So if you go to the standard at the back of your textbook, we have another table, table 5. Table 5, standard normal distribution. So we have this upper tail. So for this table, they only consider this area. So what we will have, if they ask this like this, so if we say that 0.031, so you need to find here where is the area here 0.031. What is the area of 0.31? So 0.03, and then 1. So this is here. So the area of under the graph of the area cover here is Z alpha. Z alpha is 1.8663. Actually, what is the meaning here? This is not the meaning of this table. It refer to Z alpha. Okay, Z alpha. So if we can go here, the 0.03. If we go here, meaning here you already, if here we do not know what is the area under the graph, but we can find from the Z. But for this table, actually the difference is we already know here what is P Z, and then less or what Z alpha equals to equals to apa? For example 1.03. So that is different, okay? Different. So the value that you get is refer to Z alpha for this table, but for this table we do not know the area of the graph yet. Okay? Hopefully you can differentiate between standard normal distribution for the upper tail probability, which is this graph is not represent the area under the graph, but area under the graph is here, the value of alpha here. This is the area if you go there. Okay, understood? So if we already have the answer, the total area of under the graph is 0.07. So if you go to this table, so it's quite difficult lah to find the area under the graph. You need to find it's quite difficult, but it's easy to use table 5, this table, because this table we can directly, area under graph is here, is 0.07. So 1.4, the value of Z alpha is 1.4798. Okay, so that is the difference between Z alpha and Z only. Boleh tak boleh? Boleh? Boleh Okay. Ke tak boleh ni? Boleh? Senang ke mudah? Makin senyap dah raya. Senang ke mudah? Senang dan mudah. Tak ada pilihan, minta maaf lah. Alright. So this how to solve the difference is the notation here, less, greater, less, greater. So if you go to the graph is shown you Z greater. So if less, what should you do if less? So you cannot direct lah. If less, so we have 0.25 from here, and then from table when alpha equal to 0.25, Z alpha 0.6747, so 45. So Z alpha should be negative because of the notation here, less. Alright, boleh? If Z alpha is greater than 0.5, okay, this is greater of from 0.5. So actually we cannot have if you go to the table appendix, you go now, you see the table 5. So there is no value for 0.5. It stop with the 0.4999. So if 0.5 greater than 0.5, so Z alpha also negative. So what should you do? We can measure this area. So there is no value for this. So alpha, actually the alpha that we can refer is 0.17. So Z alpha that we refer actually 2.1201. So because of this is greater than 0.5, so we put the negative. If 0.5 here, so there is negative, they also give impact, so there is a positive 1 because of the notation here, the different. And then the area that we can measure is this area 0.017. So 1 minus 0.8983 equals to 0.17. So 0.17 is from the table. Okay, table. So we get this area, and then Z alpha is equal to this. Okay, syarat dia membantulah. So you identify what is this, what is the difference here first, and then hopefully and then once you identify, you need to think, imagine the area. No need to imagine lah, you sketch the area, and then after that you think properly, logically, and then you can no need to remember lah. So if you remember, maybe you will miss something, you do not remember. But if you understand, so is more easier lah. So you punya beban pun tak banyak lah, sebab dia you fikir dia punya logik je. Okay, you sketch dia. You tak boleh imagine tau. Jangan imagine. No imagine, but you need to sketch. Okay, boleh tak? Sketch dulu. Apa-apa sketch dulu. Where is the area? Sebab dia banyak tipu daya. You know tipu daya? Mehtab no, dia tipu daya. Mehtab tak ada kat sini. Biasa dia ada. Tak ramai hari ni. 10 orang missing. Mehtab. Foreigner semua tak ada cuti lagi. Saya cakap bahasa Melayu lah hari ni. Tak ada foreigner. Right. So next is, okay. So we have mean 500, standard deviation is 100, and then what is the probability taking score below of this? So below of this score, so we will get this. So this we need to make it normal first by using the formula. X equals to Z equals to X minus nu over square root of sigma square. Standard deviation lah, SD, standard deviation here. After you get the value, so if you use table, so sometimes it's different between the Excel because of the decimal point here that we consider. So we get 1 point. Okay, sketch first. No need to imagine, just sketch first. So you will get negative 1.5. So the area cover is greater or less. So here is less, so this area. So how to find this area? So you need to make put a mirror here, and then swipe it. So actually too easy to. So we have this area 1.5. So to get this point, so 0.5 minus this area, 0.5 minus this area, actually, yeah, this area, 0.432. Okay, logic boleh saya boleh lah. You go one by one slide, and then for the maximum value Z alpha, so if you go to the question, remedial assistance will given you student a bottom 10%. What is the maximum score of the student? So this question already give the probability. What is the probability? Area of under the graph. So what should you do? So x less or equals to maximum of the value 0.1 here, and then alpha, we call it as a alpha, and then here. So once we find how to find 0.1, so from the table, so alpha 0.1, so z alpha equals to table or Excel. I didn't go through Excel yet, but later on we will go to the Excel for the exercise. But the most important is you need to understand the main idea of this subtopic. Okay, and then after you know the value of alpha, so we can equal this value, this total value is equals to this. So that's why we can therefore we have this equation, and then we solve this equation, and then we get 372. Why did we take the approximation? Because this is a discrete. Because you know the maximum score of this group of this, what is the maximum score of this group for the of the student? So we will get 372. Okay. Okay, so time for using the Excel. Okay, for the standard normal, so we use this. But for the alpha, z alpha, we use norm.inv. This is norm.dist. For the true is cumulative distribution function, false is probability density function. So nothing more. Just this is normal standard distribution. This is normal distribution. For the normal, but for the standard is the blue one here. Standard is norm.s standard. Okay. So okay. Let's go to the Excel. Boleh ke tak? Boleh. Alright. So let's go. How we will get this? So So standard norm, because of what? Normal distribution keyword here. So actually, can I use pen here? Boleh tak keluar? Okay, so masuk. Okay, whatever lah. Okay, so we identify what is new here. New is mean is 500. Standard deviation is 100. So less of this. So you just directly put what is x value. So mean value and then standard deviation cumulative. And then 350 is x, and then 500 is mean, 100 is standard deviation. So why is true here? Because of true cumulative distribution function, because of this. Okay, boleh? Okay, and then this is for standard normal. So for the standard normal, what should you do? You need to know what is the value of z here first. So how to convert this value to z? So 350 minus 500. Okay, and then divide by standard deviation hundreds. Okay, so you will get 1.15. You get 1.15. So here there is true cumulative distribution function. So 1.15. Actually this value is come from this table. Okay, this table. So from this table we construct this table. Okay, we know that mean. What is the mean of this table? Mean is 300. Okay, mean is 500. Mean is 500. You just manipulate this number. Mean is 500. So standard deviation hundreds. Standard deviation variance tak ada. Standard deviation hundreds. Okay. So yang ni kita betulkan titik perpuluhan lah. Nak tu banyak. So we format this. Format cell numbers. Okay. So variance. If the given value variance, use the formula square root of hash 5. What is hash 5? Hash 5. Okay, so this is 100. Variance apa? 10,000. Variance 100. 2 kali lah kan? 2 kali. Standard deviation. So kita buat square root of this hash 5. Okay, mean here. Mean is berapa mean yang kita nak? Mean dia kata 350. So we get this value. So mean 500, standard deviation 100. So X yang kita nak, yang ni kita change lah bila dalam exam nanti. So 350. Okay, so the value of PX here, so if less than, so we will get standard equals to normal distribution. This is a normal distribution. Norm okay, X is this, mean is this. Okay, standard deviation is this. Cumulative is true. Okay, 0.668 if less than 0.668, less or equal yang di sini dia terlebih lah. Okay, if greater, so if greater 1 minus this is greater, meaning 1 minus this. Okay, if between, so you need to change here. Okay, boleh? So just refer exactly from here. So in this table is equal to X or less or equals to X. For this table, if less, without equal here, so you consider this value. Boleh? Boleh tak?
Boleh kata.
Bagus. Macam tu lah. Ni 1, 2, 3, 4. So saya tak correct dia. So kita correct format cell. So you all buat benda ni, you all create this, and then later on bila dah exam nanti, you all guna je. Just make sure kat mana yang nak kena ubah. Macam tu je. Mudah ke senang? Mudah ke senang? Mudah dan senang. Alright. So apa lagi? Dah habis lah lecture kita hari ni. Boleh tak macam tu? Okay. Macam tu je lah. Cuba exercise ni. Cuba buat yang ni. Yang ni macam mana pula? So you create formula dia kat situ, dengan jawab soalan-soalan yang dia bagi dah. Dia dah tunjuk dah pun dekat slide ni. Dekat slide ni you jawab, cuba guna you punya calculator ni. You sebenarnya hari ni create you all punya calculator untuk you all guna untuk test nanti next week. Boleh? Untuk normal. Untuk binomial, sebenarnya you kena boleh buat exam macam ni. Hari tu saya tak sempat hajar kan. So saya rasa you all boleh cari sendirilah. Sebab dekat e-learning kita dah ada yang untuk binomial punya Excel. Cuma hari tu saya tak pergi go through every details lah. So nanti you go details, dekat sini you create you punya table, which is you boleh guna dekat exam nanti. Senang lah. You boleh tahu kat mana yang perlu ubah, tak. Boleh macam tu. Ni macam mana nak guna nak ni semua. Okay, for this, macam saya cerita lah, for this question, so for this question, you kena, kita ada, ini dia nak between kan, between, so between, kita dah kat atas. Okay, between between, tak ada kat sini tak ada contoh. Kita ambil lah yang mana-mana satu kan, yang mana yang ni kan, kita ambil yang ni 0.51, tapi kita tak ada value mean tu. Sekejap saya nak buat ni. Standard norm. Okay, when using norm standard distribution, change the score value into 2 decimal places only. So untuk yang ni kena ada 2 decimal places. Apa jadi bila you tak guna 2 decimal places? Contoh you guna 3, 4 decimal places. Apa yang akan berlaku? Apa yang akan berlaku bila you guna ni? Kalau you tak guna 2 decimal places here, what happen? Boleh jawab? Apa akan berlaku? Jawab. Cuba. What will happen?
Salah tengok kat table tu Ustaz.
Apa dia? Macam mana?
Salah tengok dekat table.
Salah tengok kat table.
Kot lah.
Jawapan kita akan jadi berbeza. Sebab dekat dalam ni kita boleh, dekat Excel kita boleh kira. Bukan nak to be, maksudnya jawapan kita dekat textbook akan berbeza dengan jawapan kita dengan jawapan dekat Excel. Sebab Excel dia boleh kira everything kan. Dekat textbook dia limit, table tu limit sampai 2 decimal places. Macam tu. Okay, dia limit kat situ lah, beza. Dia akan berbeza jawapan lah sikit. So make sure you use 2 decimal places. Okay, boleh? So how to use this? So you need to put the formula lah here. So the formula to be z equals to x minus new mean. Okay, minus mean, and then we divide by standard deviation. Divide by standard deviation 100. So you akan dapat -0.5. Okay, put this formula here. So So easy lah, later on nanti you nak apa, you nak cari this. So for this, so we will get, so PZ equals, so this is a normal, so negative and then true. So normal standard, so here normal, okay, equals to normal standard distribution. Okay, normal standard distribution. Z, what is Z value? Z value is here, and then cumulative is true. And then close bracket, enter. So okay, here because this is 0 0, right? So 0 0, so here you need to standard with 2 decimal places only. Okay, here is 2 decimal places. Format this cell, so 2 decimal places. Okay, format this cell 2 decimal places. So this cell is 4 lah, as usual. So this standard insert. Apa maksud ni? Saya nak masuk apa? Saya ingat format cell, so this is 4 lah. So number, so this is 4. Okay, so sekarang kita tahu when this is this, so if less, so meaning 1, this is equals to 1 minus this answer, so equal enter. Okay, sama tak dapat? Sama boleh macam tu je lah untuk buat table. So semudah itu je lah. So cuma you kena fix kat sini value untuk ZU, and then dia punya decimal places ya, 2 decimal places. Boleh? Actually using the change Z dekat sini ni sebenarnya situ. Okay, kat situ you change. Boleh. Untuk yang ni macam biasa, so dia adalah norm. You need to identify the area lah first. Norm distribution. Okay, X berapa? 50. Katakan kita nak ambil in between 350. Sorry, salah. Okay, sini in between S1, in between kita nak ambil 300 sehingga 600. Ya, berapa agak-agak kita akan dapat? So kita tahu yang ni untuk dapatkan formula dia, we know that to get in between, so what should you do? You need to add to area near here. So first area here, and then the second area is here. Alright, so norm distribution. norm distribution. Okay, x, what is x? X is mean. Okay, x is 300. Mean is mean is 500. Standard deviation and then cumulative true. So you dapat this distribution, this probability lah. Not yet, sorry. This is only for so how to get this distribution. So kita letak mirror kat sini. So direct lah. So kita direct daripada tu kita boleh dapat formula tu. So and then plus, okay, plus norm distribution again, 300, 600, okay, and then we have mean, and then comma, we have standard deviation, mean, standard deviation, and then true. Okay, macam tu lah. Okay, rasanya you boleh try lah this exercise. Okay, boleh try test, tengok you punya calculator tu betul ke tak. Alright, and then you boleh guna dekat ni, and then kita rehat sekejap sebelum kita pergi ke continuous correction factor, normal distribution, binomial, continuous. Boleh kita berehat 5 minit?
Boleh.
Okay, let's go. The last section before we end of this chapter. The last section. Okay, so we go here. Okay, a normal approximation of binomial and Poisson probability distribution. So what we can get here, here, we know the binomial involve only two outcome. Poisson is based on the average. So normal, we can make the binomial distribution to the normal distribution, and then Poisson into the normal distribution. And by using the continuity correction factor, 0.5 is added or subtracted based on the situation. So to make them normal, so the rules or the rules that we need to satisfy, the condition that need to satisfy is n greater equals to 30, and then both np greater equal to 5 and nq greater and equal to 5. So how to make to know what to add or subtract. So based on your logic lah, based on your logic, if you go to your book, okay, go to your book, we have a note here, page 76. Okay, here, so how to know the extract or subtract, to add or subtract the 0.5, to tambah, nak tolak ke nak tambah. So for if equal, so we can approximate. So we approximate plus and minus at the left. If less than equal, so we just add plus 0.5 here. If minus, if less, and then identify where is the direction. So x less than 0.5. Okay, sorry. X minus 0.5. Ni x plus 0.5. If greater and equal, so x less tolak minus 0.5, and then if this condition, so x plus 0.5. So this is the condition that you need to meet. Then what should you do? So there is the correction first, or you need to put the correction first. Okay, for example here, in a certain country, 45% of the registration voter are male, and the 300 registered voter for the country are selected at random. Find the probability at least 5 are male. So there is 300 voter n, and then the at least 1.15. So P equals to 0.45, n equals to 300, and then male X is defined as a male voter. So we can have this binomial distribution. And then how to shift to the normal? We want to make this distribution normal. First of all, we need to check either satisfy the rules or satisfy the condition that we can convert or not. So when we check this condition, so 135 is greater than 5, and then 165 also greater than 5. So we just have two rules need to satisfy. So this y n can be normal. This data can be normalized. So first of all, make a correction. Apply continuous correction here. Continuous correction. So P greater and equals to 155. So P greater and equals. Okay, so this condition lah. This condition, okay? This condition. So P greater. So x minus 0.5. Minus 0.5, so we will get 154.5. And then we need to find 1.54 to 5.5. So we normalize first. We normalize using the formula. So we have 135. What is 135 here? The question asks 135. 135 is mean. So we have mean here 135. So you go to your calculator. You already have calculator here. Okay. You change here. 135. Your mean is 135. And then what here? Standard deviation. You give a standard deviation or how? Standard deviation is 7.4. Standard deviation is 74.25. Where come from this number? Oh, this number is so we have this variance. So we know that here this here, the basic one is NP. NP is variance. You remember here, we want to standard deviation, right? Standard deviation in this chapter. If you go to the normal distribution, Poisson binomial. So standard variance is variance x is this. NP, what is NP? 1 minute. So we already have a standard deviation here. This is the formula for the standard deviation. Actually, like this table, I cannot find the table. So, 1 minute. Okay, something like this, but so which is NP is standard deviation. So what we'll have here, standard deviation kita apa tadi? 1 NPQ is our standard deviation. NQ 165. Okay, 165. So you dapat 12. NPQ 165. NPQ 165 darab 300 tadi kan, darab N. So 49 495 00. 495 00. Salah. Macam mana dia dapat dia punya standard deviation tu? Dia dapat daripada mana? NPQ standard normals mean variance 74.25 dapat daripada mana? NPQ, supposedly NPQ. Sepatutnya situlah variance dia. Sebab dia kata kat sini ni adalah variance. Supposedly dia dapat ni mean variance. So ni adalah variance. Meaning NPQ. Oh, saya salah darab. NPQ. N300. N300 darab P 0.45 darab lagi Q 0.55. Okay, 74.25 adalah variance. So variance 74.25 variance 74.25. So standard deviation dia dah kira. Yang ni kita format lah. Okay, tak perlu. Okay, tak perlu. So min yang kita nak, x value yang kita nak cari dekat sini. Okay. Okay. What is the value if 154.45? 154.45. 154.45. Boleh tak kita ambil direct sini? Equal of this. Okay. So 0.10. Betul tak? Okay, so kita buat dia normal. So 2.26. So 2.26. So we get this. So kita akan dapat 0.12. Okay, kenapa dia jadi berbeza sedikit berbeza sedikit dengan jawapan yang kita nak. 119 kat sini because of the value of variance kat sini 2 decimal places, tapi dekat Excel dia lebih tepat sebab dia boleh kira banyak. So kalau kita buat 2 decimal places, format cell, number 2 decimal places, berbeza sedikit, tapi tak apa. Kejap kenapa ni? Zero 0.5, 1.12, 1.012. Saya tak dapat pastikan kenapa dia ni. Mungkin okay, biarkan dulu. Saya rasa dia punya decimal ni tu jadi tak berapa betul. So dia nak greater, so kita terus direct dapat sebab sekarang kita bina calculator online kan. Okay. So untuk yang tu, and then apa lagi Okay. Then untuk this question, okay, settle out kat situ. Ni another question. This is Poisson. Macam kita nak kita nak bagi dia normal, so we need to have this, and then X is customer in 9 hours, and then Lambda is 5. So we got this. So what is the lambda for 9 hours? So you should have this, and then we get the for the normal y lambda. So they meet all the rules. We need to mean greater than 0.5. Everything is greater than 0.5. 5. So we can approximate it normal. So 350 buat correction dulu, kita tambah this, and then baru kita buat normalization. So kita dapat this. So so kat sini beza dia adalah kita punya formula. So we get, kenapa tadi? Bunyi apa tadi? Dengar tak? Senyap je kan? Ke saya lost ni? Boleh? Okay. So kalau nak masuk dalam calculator kat sini 45. So everything 45 kat sini. 45. This is 45 ke? 45. 45 min kita berbeza lah. Min kita berapa tadi? Min kita 30.5. 30.5. Okay. 30.5 standard deviation 45. Okay. So what we'll get this value. Betul ke tak? Sekejap lah. Kita kena betulkan kita punya calculator. Negatif cos 2.16. Negatif 2.16. Betul. So kita akan dapat so dia so what this 0.96 98 46. Kita dapat 47. Saya tak pasti, tapi mungkin dia punya table lah beza kat value kat table dengan kita punya ni. Almost similar. Beza satu tu saya tak pasti kenapa. Mungkin you all kena tengok balik lah. Okay, nanti kalau saya dapat detect, nanti siapa yang dapat detect inform lah. Cuma setakat ni saya tak dapat detect kenapa ada beza. Yang ni 6, yang kita dapat 7. So saya tak sure kat sini. So anything else? So this is, so you tukar dia punya value je kat sini. Make sure dia meet ni lah. Okay, so as your attendance today, okay, we will end as attendance today. Please submit the exercise, this exercise. The exercise at the Padlet, and then you screenshot the Padlet, go to the attendance link. I want you to solve this question. So the ATM. So to solve this question, you need to define first. So solve this question, and then you may leave. That's all for today. And make sure you submit this attendance. I give you up until the whole week to settle out everything. If you cannot settle out today, so you can leave. But if you want to if you want to what, you have time, you have no class, so I will discuss this. Is it okay before we end our class? You may leave if you have anything else, because we already end of our class. I think enough for today. But actually I have if you have time, you can stay a few more minutes to discuss this attendance exercise. So you want to leave, you can leave. If you want to discuss, you may stay first for a few minutes. So So what is your choice? You nak apa?
Okey doktor, terima kasih.
You nak ni. Okay. Alright. That's all. Thank you. So siapa yang nak masih stay, you boleh stay. So kita discuss sikit exercise 0.1 2.1 number 1 ni. Yang ni adalah untuk attendance you. So kita discuss sikit. Okay, so now first of all you need to define what is X here. So what is X? X is the number of students used. So what is X equals to the number of students use ATM in 1 hour, which is we can notice that there is kita boleh bagi can donate as a chi approximate to P not 5. Okay, so in bracket. This is the first information that we get. And then we know that 8 a.m. until 5 a.m. Okay, until 5 a.m. So we have how many hours? So 9 hours. 9 hours. Okay, the question asked to for 9 hours. Okay, 9 hours. So now we define Y, which is Y is, so therefore Y is the number of students, okay, the number of students use ATM in 1 hours. 1 hours untuk 9 jam ni. Okay, yang baru ni, yang 9 jam ni. So yang X yang dibagi average kan. So Y kita lambda, so lambda equals to 5 times 9. It's because of 9 hours. So kita akan dapat average dia adalah 45. So it means that Y P naught kita adalah 45. So 45 adalah lebih daripada 5 kan. So that's why dia masuk dalam this chapter lah. And then untuk normalize, kita boleh normalkan dia. So Y, okay, Y N 45 kan. 45 45 Okay. Okay, Y4545. So sekarang untuk normalize, first of all you kena buat so 45 lebih pada 10. So sekarang dia punya condition kat sini, dia kena lebih pada 10. So kalau kita tengok kat sini, dia punya condition kena lebih pada 10. Ni untuk yang ni 10. Yang tadi 5, sorry. Yang tadi 5, yang ni 10. Okay, so bila dia lebih 10, we know that dia boleh buat normal. Okay, normal, and then by using normal approximation. So apa kita perlu buat? Apa perlu kita buat? Kita boleh buatlah ayat kat sini sikit kan. By using, tengok je macam dia sedikit, and then buat correction. Okay, buat correction. So P kita equals to Y. Dia nak dalam soalan ni dia nak more than 300. More than 300. 30 student. More than 30 student use the ni. So dia is CC kat sini. Kita buat correction. P so correction kat sini. P Y nak tambah ke nak tolak ni? Greater and equals to 30.5. Okay, 30.5. Okay, and then kita akan dapat from this, kita dapat P equals to what? P equals to, okay, kita normalize dia. P, so Y jadi Z. Okay, jadi Z. So equals to, greater and equals to, okay, 30.5 tolak 45 bahagi square root 45. Sebab dia kena bahagi standard deviation kan, yang kita ada variance. Okay, you akan dapat, so you akan dapat equals to apa ni? P Z greater and equals, ni berapa ni? Cuba kira sekarang. Berapa ni? Saya tak ada calculator. Cuba kira. Kelas, ada orang tak ni? Ke saya seorang je ni? Negatif pun saya. Okay, bagus. Sebab masukkan kat sini je, baru saya terlintas, tak ingat tadi. 30, kita nak 30.5 kan? 30, kita punya ni 30.5, 45. Jadi negatif 2.16. So negatif 2.16. So dah 16 kat sini. Mana saya punya ni pengiraan tadi? Negatif 2.16. Okay, so kita dapat P. So kalau ikut manual, you kena lukis dulu. Okay, lukis dulu kan. Okay, lukis dulu kat mana dia punya position tu. So biasa saya lukis kat tepi ni lah. So lukis dulu dia punya position dia. Okay, kat mana. So dia nak more than, so dia punya ni negatif 2.16. So apa you kena buat? You kena 0.5. So equals to, untuk dapatkan area dia 0.5 P plus kalau pakai table ni, kalau pakai table biasa, plus area under the graph of this lah. So plus 0, sebab kat sini kosong, okay, so 0.4 8 4 6. So total dia sebenarnya 0.986. Dapatlah jawapan untuk you punya attendance. Okay, 847. Kalau kat sini tu dapat 47. Saya tak tahu apa masalah kat sini. Saya tak dapat identify lagi. Hari ni nanti saya identify kenapa dapat 47 dekat sini. Okay, boleh? Itu saja. Saya rasa you dah boleh submit attendance. So that's all for today. Enough. Okay.
Thank you, Doktor.
Okay. Jangan lupa submit attendance.
Doktor.